Hello and welcome to Emission Control Systems. In this lesson, we're going to talk a little bit about what emissions we're controlling and how we mitigate them, and a little bit of description, operation, and theory. So let's get started. The history of smog. What is smog? It's a combination of smoke and fog. It's kind of what we look at and go, that's kind of smoggy. Now look at these pictures. Where would you rather be? I think most of us can agree that the picture on the right looks clearer, better. But this is kind of over here on the left is what your representation is, kind of smoky fog. That's smog, and that's a byproduct of a lot of emissions from in the industrial age that we're in. So when we run a combustion engines, as we ignite this fuel, the fuel isn't ignited perfectly clean. Some of the byproduct, that the chemical makeup of that, becomes this nasty pollution. So we're going to talk a little bit about what emissions, what the pollution is, what kind of gases they are, and how we mitigate it, or how do we correct it in our environment. So a little history, California emission control. The way California goes, so goes the world. But look, we're way back, even actually earlier than 1963. 1950s is when we started recognizing that there's a problem with emissions. And that had to do with post-World War II, the Eisenhower freeway system, modern design vehicles in the 50s got streamlined. People can live further away from their work or work further away from their home, however you want to look at it. So people are driving more, and they started realizing the noxious gases that come along with the internal combustion engine. So 1963 is one of the earliest laws, requires PCV, positive crankcase ventilation. We'll talk about that in a little bit on new vehicles. Older vehicles retrofitted from a road draft tube. 66 exhaust emission standards for hydrocarbons and carbon monoxide started. We started testing them in 66, and in 70 evap fuel systems, 71 for FED. Basically, that's to contain the evaporative gasoline vapors. So as gas heats up, it evaporates. We want to try and trap that fuel, that vapor, to be reburned later. We'll talk about this later. And then NOx, NOx. The X is a variable, so it's nitrogen of oxides, and then X, how many different oxygens are on that molecule. So we started having NOx standards in 71, introduced the EGR in 72. That's your exhaust gas recirculation system. And that basically takes some exhaust gas, recirculates it back into the intake. And that inert gas can ignite, effectively lowers the displacement of the engine, lowering temperatures and pressures, and eliminating NOx. And again, NOx is part of that smog formula. And then 75, catalytic converters. No, it's not Cadillac converters. I've heard Cadillac converters often. It's catalytic. It's chemistry. It's a catalyst process. It's converting some gases into something else. So we'll talk a little bit about that. And there's a video at the bottom of this Canvas page that'll explain how catalytic converters work. Pretty cool video. I highly recommend watching it. And then from late 70s to 95, all computer-controlled vehicles were OBD1. We talked a little bit about that in that ignition video, onboard diagnostic generation 1. And then in 96, it was the start of OBD2. And a lot of that has to do with emission standards set forth by not only CAFE, but CARB, California Air Resource Board, and the Bureau of Automotive Repair. There's standards that are not just state, but also federal. And a lot of these advancements in cars come from those standards. So as much as you might hate smog or emissions, a lot of them are good. A lot of good things came out of it. And a lot of these emission control devices don't work under wide open throttle. So people delete them and get rid of them, like PCV system. We'll talk about that in a sec. Good system, nothing wrong with it. Why would you want to get rid of it? So it's kind of weird. People think this is bad and just start ripping smog stuff off. Yeah, some smog stuff is bad. I'll get that, but it kind of got a bad rep in the 70s before technology can really support it. Once technology was able to support these mitigation procedures, actually it was pretty good. So, and then we monitor it through smog inspection. I'd imagine if you're a registered vehicle owner and driving this state, you've gone through a smog check. So here are the different types of smog checks. You have your initial registration when you move into California, when you purchase a vehicle, change of ownership when the car is sold. So if you sell a car, you have to smog it. If you're going through internal family, though, you don't have to. Immediate family, you don't have to smog it. And then there's biannual. If you own the car, just every 2 years you have to smog it. And then new vehicles are exempt for first 4 years. And this is it just changes all the time. It really does. there's so many things to this. Depends on what county you live, whether or not you have to do biannual. Sometimes you only have to smog it when you buy it, and then you're good from then on out. It depends on how many people live in your county, how many cars are there, etc. And then the new vehicle exemption, it's exempt for 4 years unless you keep it. Then some cars are exempt for 6. If you sell it, it's only good for 4. But diesels aren't exempt at all, and hybrids have an exemption. There's so many different little nuances that you would have to be a smog tech, and this class is just the intro to that. So the point is, there's lots of smog inspections, and when and how and you have to do them are heavily mandated by the state. We have a 2-speed idle test, and this is what we use here in Butte County. Basically, you have idle and a 2500. They're going to check this, make sure the emissions, and this is for 99 and older vehicles. 2000 and newer, we have a different type of system that plugs into the computer port. You don't actually check the exhaust gases. On a TSI, 2-speed idle system from 99 and older, which is called a bar 97, you would actually put a probe into the exhaust pipe, and at idle and 2500 RPMs, they would check emissions, and they would check for certain gases we'll talk about in a minute. You would also do a TSI if you were in an advanced area, but you had a 4-wheel drive, all-wheel drive that can't be deactivated, because those vehicles have to be tested on a dyno, which we'll get to in a second. So then if your car had a 4-wheel drive or all-wheel drive that cannot be shut off or deactivated, you would do a TSI, even if you're in an enhanced area. So the 4-gas does not test for NOx. We don't test for NOx here in Butte County, and we'll get to those in a second. And then there's the ASM test. This is in enhanced areas. Think big cities, San Francisco, Sacramento, LA, lots of people. So acceleration simulation mode. It uses a dyno, and they're going to load the engine at 15 miles per hour, 50% load, and 25 miles an hour, 25% load. This tests everything that the TSI does, but also checks the engine under load, and is testing for NOx. So care a little bit more about NOx because they have more of a smog problem. So those are the types of smog tests. Again, we do them either every 2 years, or when you sell a car or move into the state. And that there are little differences on what kind of vehicles, again, whether or not you have to smog them. So 5 gases. We hear about the 5 gases as an automotive tech. The main gases we're talking about are HCs, hydrocarbons. That's your raw fuel. CO, carbon monoxide. This is a byproduct of incomplete combustion. And then CO2, carbon dioxide. And then NOx, of course, oxides of nitrogen we talked about, and oxygen, O2. Now, the 3 main gases are hydrocarbons, CO, and NOx are the ones we're looking at for pollution purposes. If you're in an area like Butte County, HC and CO, these are the 2 gases that we're monitoring for. So hydrocarbons, again, like I mentioned, is your unburnt fuel. Fuel vapors from the gas tank, unburnt fuel from ignition misfire, unburnt fuel from lean-rich misfire, etc. So carbon monoxide is that byproduct, either rich mixture, defective cooling system, poor compression, gives you that incomplete burn here. Incorrect cam timing, retarded cam timing, restricted intake air filter, normal in CO, and catalyst-equipped vehicles is 0.5 or less. This is for diagnostic purposes. But basically, if you're seeing CO, then you're either rich or something's causing an incomplete burn. And then carbon dioxide, this is an indicator of efficiency. A tech will use this and O2 level to monitor efficiency of an engine. So carbon dioxide is, although it's a greenhouse gas, it's not one that we are particularly worried about in California, measuring on the car. Oxides of nitrogen. So if you get high pressure, high temperature in the combustion chamber, you're going to create NOx. Over advanced timing creates this. Defective cooling system, your engine runs too hot. Combustion chamber deposits, that carbon inside there can also increase your compression ratio, which will increase pressures, and that can create NOx. Your EGR is not working. Excessively lean, which increases your temperature, which creates NOx. Incorrect fuel octane rating, and normal NOx levels vary with engine type, and that is very true. Depends on the design of the engine. But basically, think of NOx. If you have high NOx, something's causing high pressures or high temperatures in your engine. And then there's oxygen. O2 makes up approximately 20% of the air we breathe. The amount of oxygen that comes out of the exhaust pipe depends on how well the catalytic converter is working and how well the engine is tuned. So again, we use O2 and CO2 down here together should equal about 15%. That gives us an indicator of how efficient the engine is and how efficient the cat's working. Now, that's not a test you would do to measure if the cat's bad or not, but that's just something that gives a technician a heads up on what's going on with the engine. So basically the goal of fuel management is stoichiometric. This is our air-fuel ratio, how many parts air to fuel. So 10 parts air to 1 part fuel, 18 parts air to 1 part fuel. So this is lean, this is rich, and these are the different gases. So as we come through here, you got CO2 spikes right here, comes down. As we mentioned, we're not too particularly worried about it. NOx spikes right here also. CO, carbon monoxide, you see it starts off over here when it's rich and then comes down. But as you go lean, HC, this green one's going to spike as you go lean or rich because you have a misfire. That creates that unburned fuel. And O2, as you get leaner, you get higher O2. So ideally, this gray area is where we want engines to run, maybe a little bit below the gray area, but somewhere in this area right here, right about 14.7 stoichiometric, but high 13s, low 14s is where you'll see cars mostly run. And then you're not worried about CO2, remember, NOx we are. So we figured most gases are low at this range, this air-fuel ratio, except NOx. And then we'll just fix NOx with what I call a Band-Aid or add-on part, and that's your EGR. Okay, or variable valve timing, depends on the engine. Can handle and fix those oxides of nitrogen. So again, ideally we're going to be right here, 14 or so, 14.7 air-fuel ratio. And that's the stoichiometric for gasoline. Other fuels have different stoichiometrics. So emission control devices, what are we talking about? We got a positive crankcase ventilation, PCV. It's going to help with those hydrocarbons that we'll talk about in a minute. Secondary air injection helps with hydrocarbons. Charcoal canister helps with hydrocarbons. EGR valves, your NOx. Catalytic converter, you have a two-way, which is hydrocarbons and carbon monoxide. And then a three-way, you add in the NOx. And again, there's a video at the end of the bottom of this Canvas page that'll help you understand that if you're looking at this in Canvas. Excuse me. So PCV, positive crankcase ventilation. Basically, here's what the PCV does. Remember way back when we talked about the engine in the four-stroke process, we have intake, compression, power, exhaust. We have that combustion chamber, we have a piston, you have rings. A couple of those rings are your compression rings, and you have an oil scraper ring. Well, those compression rings aren't perfect. Some of that compression, when the cylinder ignites, some of that pressure that's pushing down on that piston makes its way into the crankcase. Along with that pressure is going to drag some fuel. Now, fuel moisture is not good lubricant. It's going to ruin bearings and that hydrocarbons, and the fuel evaporates, and on a normal system with a road draft tube, it would just go out to the atmosphere. So they sealed the crankcase and use this PCV system that's going to remove hydrocarbons from the oil and moisture from the oil. It also removes pressure from the crankcase. So all that pressure that would push out and cause seals and gaskets to leak no longer happens. So, ooh, bad, emissions, smog, yeah. We wouldn't want our engines to not leak oil and not leak hydrocarbons. This does not rob any power. It just prolongs the life of your oil and prolongs the life of your engine, prolongs the life of your gaskets. All good things. PCV is a very good system. So old school road draft, that pressure would just right here and spew on the road. Okay. So we get rid of that. We add this PCV valve, but this one has a regulated orifice in here. It's got a spring, and basically it's going to suck to the intake manifold out of that crankcase. Well, anytime you suck air to the crankcase, you have to replace it with fresh air. So we bring fresh air from a filtered source behind that air filter, and that brings fresh air into the crankcase to replace the hydrocarbon oil air that we're sucking out, and then reburn that in the engine. So that air we pull out of the crankcase goes through the carburetor or the intake manifold, depending on the engine, and is going to actually remove that hydrocarbons and then bring fresh air into the crankcase, replacing it. Okay, that's basically it for this video. Stay tuned for part 2, and we will continue our discussion.